Hello, everyone. Welcome to today's webinar. It's titled Efflorescence or Latex Migration, How to Tell the Difference, How to Repair, and How to Prevent. I'm Jim Olson with the National Tile Contractors Association. I want to welcome you to today's presentation, and I know you have a busy schedule, so thanks for taking time to attend today. The webinar today is sponsored by MAPEI. Before I introduce today's speaker, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in any question that you might have. We'll answer those questions at the end of this presentation. If the audio is poor on your computer, call the number on the invite to this webinar and listen on your phone. All NTCA webinars are currently available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This will give you easy access to watch and or share all current and past programs at your convenience. All right, I'm happy to introduce today's speaker, Nick Valenti. He's been with MAPEI since 2012 as the technical expert for the UltraCare line. He has more than 35 years of experience in the sealers and cleaners product line. While his experience includes an in-depth knowledge of products, Nick also understands the major issues and problems that can arise with the surfaces to be protected and has solutions for these challenges in charge of training MAPEI's sales and technical services team. Nick is even more importantly the in-field resource for MAPEI's customers and end users. Welcome, Nick. We look forward to your presentation.
Thank you, Jim. I appreciate it. I'm looking forward to it as well. Thank you, everyone, for joining. I chose this topic of latex migration and efflorescence because these are two of the very common things that in our business that just don't seem to go away. And with the advent of really large format tiles and highly modified setting materials, so there's a lot more latex involved and a lot less areas for moisture to leave and for moisture to come in. So by combining the two, I think you'll be able to find out the differences and how to repair and prevent these two phenomenon from occurring. So let's get into it and let's take it from here. So a simple question, what is efflorescence? And by definition, it's the migration of soluble salts to the surface of a porous material, such as concrete, stone, brick. And as a little side note, in French, it means to flower out. And that is sometimes why it's referred to as a bloom, an efflorescence bloom. Portland cement-based setting materials and grouts, concrete subsurfaces, many natural stones and clay tiles contain free lime and or soluble salts. These minerals are brought to the top by capillary action and become visible after the water has evaporated. Although efflorescence can clog the pores of a surface and cause spalling and other types of damage, it's mainly considered a cosmetic or aesthetic issue, not a setting issue or a trade issue. And the causes. A lot of things that can cause it, and you'll notice in the presentation that there's going to be one common denominator, but according to the Portland Cement Association, and you'll notice also I've gone a little bit out of pocket on the tile side of things, and I went to some of the other areas of our business that we're involved in, like the formulations that we deal with, to give an answer as to some of the other large companies that are involved in this and what their technical information is about this. And according to the Portland Cement Association, there are three circumstances that can cause efflorescence, and one of them, there must be soluble salts, soluble compounds, and it's got to be in the masonry or the stone, the grout, the setting material, joining materials. A second item is moisture. And a third is the evaporation or hydrostatic pressure, causing that water to come up through the system and bringing the minerals to the top, usually as a white deposit. If one of those characteristics is eliminated from the equation, efflorescence can't occur. So take out moisture, soluble salts don't move. Take out soluble salts, there's nothing for the moisture to move. And if you don't have evaporation or any type of hydrostatic pressure, nothing happens. So take one out, none of the other things happen. And according to the concreteconstruction.net, there's a fourth circumstance, and that's cool sustained temperatures, usually less than 50 degrees. And this is why you'll see an uptick in the efflorescence complaints during cooler months, where you have a slower evaporation, slows down how fast these materials can dry, leaving them moist for a long time and allowing them to start coming out, usually after it has sat for quite a bit of time. And continue, calcium carbonate is formed when leached calcium hydroxide, which is found in concrete mixtures like grouts and mortars, reacts with the available carbon dioxide in the air. When calcium hydroxide is a hydration product created by the chemical reaction between Portland cement and water. The salts are readily soluble in water and are brought to the surface by capillary action, either by evaporation or hydrostatic pressure, wherever water is present. Other contributing causes: contaminated water or sand containing soluble salts, water containing excessive mineral content, such as well water that's used for the mixing of the grout and also for the setting materials, and also used for tile maintenance, like putting cleaners into well water that's unfiltered. So the water should always be considered potable or drinkable water that you use on the job. I've actually been to job sites where the water is being shipped in 55-gallon drums or in shipping containers, bulk containers, so they have good water on premises instead of what's being used on the job site. Mixing excessive water into your setting or your grouting mixtures also can lead to efflorescence bleed. Excessive water and soaking, and during the cleaning, too much water being used to rinse off the tile after it's been grouted. Re-temping the grout by adding water is also a concern, because you're adding more water than the label describes and wants you to use. I'm in the business of helping write these labels for the care and maintenance side. When it comes to the concrete side, the cement side of the business, they add a particular measurement to that bag of material ratios that much smarter people than me put together. When it says add 4 quarts of water to X amount of powdered material, I'm pretty sure they want you to add that amount, not less, not more, and not mixing it to where it's, quote, peanut butter consistency. Although that's what we think is right, it's good to pay attention to what the manufacturer is recommending, because that's always what they'll lean on whenever there's a question. The water penetrating a soluble salt contaminated grout joint in a setting bed or cementitious substrate and wicking to the surface. So they can come from exterior as well. Coming into unprotected grout, coming out of the unprotected grout brings the salts to the surface. And using plastic instead of breathable paper or craft paper when protecting the floors. Plastic doesn't breathe. You need a breathable type of surface like the craft or other types of cardboard type paper that can be used to breathe off the moisture and not trap the water that can cause improper curing of the grout. Are there different types of efflorescence? And there are 2 types. One's primary and one's secondary. In the primary efflorescence, the salts are already present in the materials, and the water comes from the sources such as moisture in the setting materials, pipe leaks, poor flashing at the installation of the flashing, or other external sources like rain, sprinklers, a flood moving through the system, bringing salts to the surface. Primary efflorescence also occurs during the initial curing phase of the cement-based materials in the brick and the stone. Secondary is a reverse process where the salts originate from external sources and then carried inside the system in solution. De-icing salts would be an example of that type of secondary efflorescence. Everything's cured, but then they come back through with salts. The salts go mixing with the water back into the grout, and then they start bringing their way back out, causing efflorescence on the grout to appear. Secondary efflorescence isn't the result of the forming or curing of cement materials or water intrusion, but from invasive materials such as chlorides. Steel reinforced bridge or parking garage is a really good example of where secondary efflorescence can occur. In the northern climates of the US, saline solutions are used to de-ice the roads. These saline solutions absorb into the concrete where they can begin to dissolve the cement structure of the concrete mixture. In situations of heavy efflorescence, stalactites can also form as a result of the dissolved cement hanging from the cracks that form in the concrete. This degradation of the concrete is vital to the structural integrity of the concrete and is a traffic and building maintenance concern. If you look at the pictures, you'll see these things hanging from the ceiling around the water pipes, especially around the connections. And it can cause the rust and it can cause degradation of the cement structure and even affecting the reinforcement of rebar, corroding it, weakening the system. And it can lead to serious issues as far as the traffic and buildings and the structure of parking garages and things of this nature. The different types of efflorescence, and there's always, most all the time, we're always concerning ourselves with white efflorescence, and because that's the most common. But there are, depending on the types of the minerals or salts in the surface, they can appear yellow or brown. Vanadium sulfate salts, vanadium sulfate, can cause to appear as a green or blue, like what's shown on the brick on the right. Brown, seen in the limestone, some sandstones, can result from alkaline solutions high in hydroxides and carbonates, causing a more brown look to appear on the surface of the tile. So it's not always white and powdery and kind of fluffy, but it can be other colors. All the different sources and types of salts that are in construction materials that can contribute to efflorescence, and bear with me on the chemical names and what they are, but these are all very real in all the mixtures of grouts and setting materials that are out there, and they contribute to efflorescence. Calcium sulfate is probably the number one, and it's found in brick and in gypsum and other masonry materials. As I mentioned before, there's vanadium sulfates, sodium sulfates, potassium sulfate, which is found in a variety of reactions with cement and brick, particularly. Calcium carbonate in pretty much every mortar, grout, and natural stone, such as marble and travertine, lots of calcium carbonate. Sodium carbonate, it's usually is a ingredient in the formulation of mortars and grouts, just as potassium carbonates are. Sodium carbonate and potassium carbonate, without getting geeky on the description, are twin sons from different mothers, but they are also used in mortar formulations and grout all the time. And magnesium oxides are also very, very common in these types of mixtures. And in the photos, you can see a variety of types of efflorescence. I mean, coming out directly through the face of the brick, coming out mainly in grout joints sometimes, appearing as a white fluffy material on the surface of the tile, and of course in the mortar that's being used as a contributing factor as well. So once you find it, what do you do with it? A lot of times, before I go into the slide, I ask, when did it happen? When did you notice it? Because if you just noticed it, you might want to give it some time before you go after it aggressively with chemical solutions and things of this nature, because if it's an early efflorescence, it may continue to bloom, and all that work will be for naught, because all you did was take care of the surface, and you didn't give the surface actually time to bloom out the efflorescence, and you interrupted it too early. So sometimes a wait and see approach is the best. In other words, is it getting worse? Has it gotten better, or has it stopped? If it's reached the point of looking like it stopped, that's when you might want to start attacking it with other things other than just mechanically brushing it off. I'm not telling you not to brush it off in the early stages. You can use a stiff nylon bristle brush to move it off of the surface. I would be very careful if you use anything than a nylon bristle brush. Some brick walls, exterior brick walls, pretty durable material. You could probably get away with using a wire brush You can get away with it, but most of the time when we're dealing with this stuff on really nice porcelain tiles and things, a metal brush would be a way overkill. I would stay with a medium nylon bristle brush, and that'll mechanically remove a lot of the material off the surface that you can sweep off of at that point. Pressure washing, now that sounds a little contradictory because a lot of this is, as I mentioned before, there's one common denominator, and that's water. So pressure washing does add water to the system, but it's also effective on exterior applications like walls and columns of buildings and things of that nature that have efflorescence, to blow it off the surface, let it air dry quickly, which it normally does. And that way you're not introducing a whole lot of water to the back side of it and then allowing it to come up to the front. You're mainly hitting it with surface water, and it allows it to come off a lot quicker. Use a wide angle tip. Don't use a pointed narrow tip. You'll etch or even cut into the grout or even remove it if you're not careful. It does add, like I said, more water to the existing issue and can cause more salts to migrate, but it's also it may be necessary to brush and rinse while washing anyway. So during the washing with a pressure washer, you might have to have someone coming behind you scrubbing with a nylon bristle brush, and lightly removing it with water. And then there's also a chemical removal. You can use mild acid solutions because these are salts and they react well to a mild acid solution. Product in the UltraCare line, and there are other available, is UltraCare sulfamic acid crystals. It's a crystal that you would add into water and mix according to the instructions. Pretty much all the sulfamic acids are the same. It's one product that we as a manufacturer truly don't make. We import the sulfamic and we blend it into our product use. We sell it in crystal, and the blending is done in the field. I would not use acid on acid-sensitive surfaces, polished marble, travertines, limestones, and even polished concrete. I mentioned polished because those surfaces will show etching with a simple acidic solution such as white vinegar that you can actually ingest. So something as simple as a white vinegar on polished marble would take approximately 1 second to etch that surface visibly. So mopping your floor with vinegar and water, that's what I usually get. That the floor is being maintained by an outside party. They're using vinegar and water because they were told to, and the marble floor loses its luster, and that's where you'll get damage from an acid-sensitive surface. But these will all help remove acid remove efflorescence. Mild acid solutions like sulfamic acid is a go-to. Another one, and if I'm not mistaken, is mentioned by the NTCA, and that is phosphoric solutions work as well. How to remove it? Using products like the sulfamic work very well to remove it off of the acid-sensitive surfaces. There's a little before and after photo on the left to identify that. Mix it according to the instructions, apply it to the surface. It'll dwell for only a short period of time. A little bit of agitation may be necessary. Recover that material off the surface, and then I neutralize after every time a mild acid of any type is used by using a slightly alkaline pH cleaner or a neutral pH cleaner to do a final rinse that does neutralize and balance the pH of the floor. It doesn't let that acid linger, which can reactivate, by the way. When the water goes away, the acid doesn't. And when you water rinse, you can reactivate that acid, and then you may even start noticing a bleaching of your grout color because of that acid that's still left behind. So always water rinse and always neutralize that with a neutral pH cleaner to chemically neutralize the surface to balance that out. Ways to prevent efflorescence from occurring. One, try to stay away from water type applications. That's where you can run into the most of the problems. But use the amount of the water that's or additive specifically recommended by the manufacturer. That's really important. As I mentioned before, those measurements are there for a reason and are balanced and tested. Beyond those, and there's tolerances on both sides, too little or too much. There are tolerances weighed into that. but it's always best to defer to the manufacturer's written recommendation, because that is what they're going to defer to if there is a question that comes up later on performance. So pay attention to the weight amount of water or additive that's being used, and additives such as latex additives, for instance. So pay attention to what they recommend. Don't get too creative in the field. Follow the instructions, and you'll always stay on point when using the product correctly. Maintain the installation at or above the minimum temperatures that are on the manufacturer's label. We all know the trials and tribulations of working in too cold or too hot of weather. Too cold slows things down significantly, allowing the water to sit for really too long in the system. Working in a hot application allows things to flash off, not allowing the water to stay in long enough. So there is a balance. Try to keep it no lower than what the minimum temperatures are, and as well as the maximum temperatures. Install the grout as firm as possible. In other words, pack it into the joints. Air pockets, in other words, or skim coating the grout joint is very common. So when you are grouting, it's always important to pack the joint as firmly as possible. The concept is to fill it from bottom to top, and then do your cleanup, and the grout should be slightly below the surface of the tile. Fully packed grout joints are really what you're looking for. And always allow for the proper cure time before assessing the correct color, or if efflorescence is occurring. If you minimize the amount of water during the cleanup, that helps as well. This is a point we talked about earlier as well. Too much water in the cleanup by super wetting the water or super wetting the floor with water can cause issues that we want to try to avoid. Using craft or breathable paper, again, another point we've talked about, instead of plastic sheeting that won't breathe. So craft paper or any type of breathable paper would be a much, much better idea. Don't trap the moisture, let it breathe out. Using moisture mitigation membranes in the setting material, in the setting bed, when excessive moisture is detected, particularly by using moisture meters. You need to be within certain tolerances for the application. And this a lot comes into play, not just with tile and stone, but especially like other types of flooring that would be highly sensitive to moisture. But in the tile and stone side, it's equally as important to make sure that that moisture is put to bed by putting a moisture mitigation type of membrane as the beginning of a setting bed, the sandwich, you might say, from the floor up. And using grouts and mortars that reduce the possibility of efflorescence. Most of the efflorescence occurs with Portland cement, which is high in lime content. But the new calcium aluminates instead of calcium carbonates. Calcium aluminate formulations are the grouts that have a reduced possibility of efflorescence, and they're also considered efflorescence free. That's a kind of a broad statement, but efflorescence, it does definitely cut down the amount of efflorescence that can occur if it occurs at all. What we're doing by making these types of products is reducing the possibility so it doesn't happen on the job. Using a Portland cement grout may very well happen in that situation, but using a calcium aluminate would reduce that significantly. Also, sealing the surface with a penetrating type sealer, sealing the grout with that type of a sealer is highly beneficial. These products, penetrating type sealers, impregnating sealers, are formulated by all of us in the industry that have high vapor permeability, meaning they breathe. Anywhere from between 98 to 100% of the water can come out in the form of vapor, because we all know from that chemistry class that you took in high school that water can change form. It can go from liquid to a solid or liquid to a vapor. For those of us that did not completely fall asleep to those classes, we kind of remember that. So sealing the surface with a penetrating sealer will allow the transmission of water out of the system. But that matrix that the sealer forms in the substrate, like in the grout, it doesn't allow the minerals to come through. It's too tight for minerals, but open enough for the vapor to come out. And that controls efflorescence a good 95%. I will give Mother Nature a hefty 5% there, simply because if she wants it to happen and the conditions are right, there's no sealer and there's nothing you or I can do to stop it. It still can happen, but it will be highly reduced by using a good penetrating sealer. Doesn't have to be a top line oil repellent one. Just a good penetrating sealer will work well to control efflorescence. After it's been successfully removed and the grout color is satisfied, everybody's happy. Again, applying a high performance sealer is really beneficial. It'll reduce the moisture penetration. In other words, water coming in, it stops that. And it prevents the wicking of minerals to the surface. As I mentioned, the matrix is too tight to let the minerals come through, but it's open enough to let the water come through. UltraCare has a couple different ones, Penetrating Plus and Penetrating SB. The Penetrating Plus is a high premium water base penetrating sealer, and the Penetrating SB is a high performance solvent base, hence the name SB, stone, tile, and grout sealer, for the option of water or solvent. Both of them are VOC compliant, and they are able to be used on a variety of stone, tile, and grout surfaces. They do effectively go 90 to 95%. I went real conservative on that in controlling the efflorescence, but unless the root cause is determined and addressed, the efflorescence could return. In other words, if you got a broken pipe, the sealer is not going to stop it. If you've got a flashing that is not installed correctly, efflorescence is going to continue to happen. So unless that root cause is determined and addressed correctly, efflorescence can return. It should not be nearly as much as what was initially formed, but it's still a good practice to make sure that that root cause is taken care of before you move forward. On to latex migration. Now, this is where sometimes it's identified as efflorescence, but there are some distinct differences. And for the record, when you do have latex migration, it can bring the minerals up with it. So you might have a mixture and not know it, but that's all part of it. What is it? And well, it can appear as a clear liquid that dries to a white, crusty residue, and it can be sticky, a rubbery material that has a vinegar or an acrylic smell, or sometimes no smell at all. It also can appear as a white, crusty residue on polymer modified grout, especially if the grout is subjected to excessive moisture before the polymers can actually coalesce and cure. Here's a comparison of the two. On the left, on the column, you see the efflorescence on the brick, and you notice that it's on the face of the brick, not just on the grout. But on the right, you'll see latex leaching out of the grout, because that's the only place it can go. In that application, you have porcelain tile and a grout that is subject to an efflorescence or a latex migration. And you'll see it comes out of the grout because that's where it's going to come out, and it drips down the side of the tile. Also, unlike the surface on the left, you see it looks like it's dripping down. In some cases it is, because it could very well be latex coming out as well, and you'll get the two of them happening. But for clarity, it's sometimes confused with efflorescence. And one visual difference between efflorescence and latex migration is that latex migration almost always starts in the grout joints, and it can end up on the surface of the tile. And whereas efflorescence can manifest on the surface of the tile, such as on brick and stones that can contain minerals that can come to the surface. So from just walking up to a job to determine what it is, keep that in mind. If it's widely seen on the surface of the tile, it's most likely efflorescence. Coming out of the joints and dripping down the side of the tile on a vertical application, for instance, that'll tell you it's most likely latex. There's the common sources and causes, as the same as efflorescence. There are a variety of different types of polymer additives, and they're used in the cement-based grouts and setting materials. And the additives can be either a powder, like a latex powder, and they're mixed into the grout during manufacturing, and they're activated when you add the water to make it the mud that it's supposed to be. Others are liquids that are mixed into the grout at the point of use, and they're used instead of water. So each of them have their superior properties, such as improved chemical resistance, flexibility for unstable substrates, for instance, increased bond strength, reduced porosity. So the polymers in the mortar bed are not fully cured, and cold, damp conditions during or right after setting or grouting can cause latex not to cure, leaving it in a kind of a very moist state. And then that moisture's got to find a way out somewhere. Water leaks, broken pipes, floods, those types of things can also cause latex migration. Rain, a significant amount of rain before and immediately after grouting can be a problem. Poor drainage in areas can cause latex migration. And a big one that seems to occur, particularly on commercial exterior jobs, improper installation of the roof flashing, and that allows water into the system. The metal cap isn't installed over the parapet of the roof correctly, or not at all, allowing water to pour into that surface and getting behind that tile. And then the grout guy comes in and he grouts that tile into the system, and then comes back and finds that there's a latex migration because of trapped moisture. Some of those large format panel tiles that we're dealing with now, these things are huge. Once they're stuck to the mud, there is no pulling that tile off to find out if it's got proper coverage on the back. Once it's on, it's on. The vacuum seal is not going to break easy without destroying the tile. And in this scenario, that's what I put in scenario 1. Consider an exterior wall installation of low absorption gauge porcelain tile over a waterproof membrane set with large and heavy tile mortar and a highly modified latex polymer rich mortar, but not protected from the environment. It rains the same day the tile is installed or soon after, and the entire installation takes in water. Tile contractor shows up the next day, grouts the wall, and is surprised when the grout has latex leaching down the face. And the second situation would be a similar situation that can occur when there's a conflict of work schedules on the job. The tile's installed, but the roofer doesn't install the metal cap on the parapet until weeks later. The framed-in cement board has topical waterproofing, a thick bed of thin-set mortar, and low-absorption porcelain tile installed. Then it rains for 2 days, and you end up with latex migration. What happened? Well, in both of the cases, the installation systems took on water after being installed. And again, you see the common denominator here between efflorescence and latex migration: water. Once the tile contractor grouted, the water in the fresh mortar bed was trapped between the low absorption tile and then in this case, gauged porcelain, less than 5%, 0.5% absorption, half of 1%. Water doesn't come out of that easy. It's going to take the path of least resistance. And if it can't get to which is the grout, and if it can't get to the grout to come out, it's just going to sit behind that tile forever in a liquid state. And the waterproofing membrane, leaving only the grout joints as the path out, which I just mentioned. This can also happen due to poor installation or no installation of flashing, lack of sealants, and these types of things. It's important that you consider protecting the installation by tinting on the exterior if it's possible. Make sure to use quality mortars that meet ANSI A118.15 and verify the coverage by removing random tiles occasionally to make sure they are covered correctly. Again, on the large gauge format, you better apply it right the first time or there will be a problem. Communicate with other trades and discuss your installation needs, telling them dates of completion, how long you have to be off the floor before they can come in. These conversations don't go well a lot of times, we all know that, but it's important that they be done. Confirm that the sealants are installed, flashing is done properly, and all roofing caps and flashing are directing water away from the installation and not to it or over it. And how to remove latex that's come to the surface. Removing latex that's leached can require using solvents and or strong alkaline cleaners, alkaline-based cleaners. These cleaners usually have a pH of over 11 up to 12, even higher in some cases, depending on the amount of potassium hydroxide they may have in the formula, but it can be a highly alkaline cleaner. along with vigorously scrubbing the area. Again, I like medium nylon bristle brushes when it comes to removing latex from the surface. Choosing the right product for the job can require field trials before finding the right product or combination to efficiently remove the residue. In other words, it's not a once and done. You may have to try one or two or even more, or a combination. Ultra Care in the MAPEI line, the Ultra Care line offers several choices. And for light residue, we would suggest using a heavy duty stone tile and grout cleaner, which is alkaline. For medium to heavy residue, you can use our heavy duty sealer and coating stripper, a very, very friendly, easy to use stripper, quite effective for removing latex film, acrylic film, waxes, even more stubborn types of things, paints and things of that nature that have been spilled onto the floor. We also have a third product, abrasive surface cleaner, and it can be combined with either one of them, the heavy duty sealer and coating stripper or the heavy duty stone tile and grout cleaner. The way to do that is to use the product first, like the heavy duty cleaner, use it first, let it dwell. And before you go to scrub, add the abrasive to that mix, right on top of it. Abrasive cleaner doesn't require dwelling like most cleaners do. It works by abrasion. The abrasive that's in the cleaner is calcium carbonate, marble dust. So it's safe to use on pretty much every polished marble surface that I've tried it on. Marble dust is marble dust, and according to the abrasive, the Mohs hardness scale, you can't scratch something unless what you're scratching it with is harder than the surface you're scratching. In other words, you could not scratch your fingernail with your own fingernail. They're the same hardness. And that's why we choose abrasive surface cleaner and use calcium carbonate in that formula as the abrasive, so it's safe for use on sensitive natural stones. Now, with that being said, I would always tell you, test it first, because somewhere, somehow, there's a marble out there that will get dull. It's not likely, but because I've said it, it probably will happen now. So always test it first. The first thing to do in the line of defense to remove latex migration is start by mechanically dry or wet scrubbing the visible latex. Use a non-metallic scrub pad or stiff nylon bristle brush. Don't scratch the surface of the tile. That's not your point. The point is to remove it. Pressure washing is acceptable, but like I say, it will add moisture to the surface. So make sure that you get it off, let it dry, and then address any hot spots with a dry bristle brush. Again, for the light residue, use an alkaline cleaner like our heavy duty stone tile and grout cleaner. For the heavier stuff, use Ultra Care heavy duty sealer and coating stripper. And and also you can add abrasive surface cleaner to that, like I mentioned before. Not necessary all the time. Either one of those cleaners might work the way we expect them to, but having that extra oomph with the abrasive does certainly help a lot. How to prevent it. Now, this comes right out of the current NTCA manual. Use only latex additives that are recommended by the grout or mortar manufacturer for specified use. I owned a chemical manufacturing company for many years, and I had many people ask me to make an additive for grout. My question to them was, what's going to happen when something goes wrong? Who was at fault? And by using the products accordingly, and I, as a manufacturer, I could not make a product that stayed up to date with each and every formula change that a manufacturer made and test them all the time. So I've never been a big proponent of using third-party mortar additives or grout additives with a specific grout. If it's a MAPEI product, use a MAPEI approved additive, and the same with any other manufacturer. Always mix it correctly using low RPM. We're not a high-speed shearing towel is not necessary. We're just using slow mix blending here, about 300 RPM or less. It should be stiff with no slump, and pay strict adherence to the manufacturer's recommendations and the mixing and using. For wet uses like swimming pools and gang showers, allow the installation to cure up to 60 days depending on the temperatures, humidities, and water exposure. Getting onto it and using it too quickly can cause a lot of problems. So it's pretty common knowledge too. These things have to cure out a specific amount of time, and that can go for anywhere from 2 weeks to about 60 days, a couple of months. Protect the installation from weather extremes like freezing or rain, so it's important to schedule that accordingly. We are weathermen, whether we want to be or not, so always pay attention to the weather, particularly on exterior applications, and especially during the initial curing periods. It's really important that these products get a chance to coalesce, cure, and that takes time. Before grouting, allow a minimum of 48 hours for any excess moisture in the setting bed to escape. Consider your geographical locations, weather conditions, tile size. All these things matter. So it's always good to do a little homework before you actually start grouting and getting your installation set. Check the flashing at the roofs, around the windows, any openings like that. And check the expansion joints or any other areas that have been caulked for possible reclaimment. And caulk immediately if possible, right after grouting, especially where walls meet floors and your critical areas. Case in point, I was called to look at a job here in Tampa, and it was a very well-known celebrity. And there was about 3,000 square feet of limestone, Indiana limestone, and 1 6-inch drain in 3,000 feet. The floor was not pitched off away from the house. It was actually pitched to the house, and water was gathering by the curb of the door and the floor. It turned out that it was because the consultant had made this mistake, and everybody followed it, and it ended up being quite a fiasco. But it was evident that there was not enough drain, floor wasn't pitched, and it was a pretty simple remedy when the word jackhammer was ripped out. That's what happened. Preventing it continued, avoid installations in wet areas if possible. That's not always possible, but if possible. If water cannot be avoided, use an approved waterproofing membrane as part of the system. Do not use setting materials or grout below the minimum recommended temperatures. That's really important. And the same for the slab and the stone and the tile. Make sure that everything's cured out properly and at the right temperatures before we start using the setting materials and put tile on top. Protect the installations from weather if possible. Again, just simple forecasting might be a good idea. Confirm that all the roofing details have been completed. The metal cap is installed on the parapet. It's all sealed properly. Sealants have been used correctly. And submerged applications have to be fully cured. And somehow that sentence didn't get completed. My apologies to you guys, but TCNA also does weigh in on that as well about giving the proper time for full cure. And a final note, latex migration is nothing new, and it's been around for years, and we're seeing an increase today due to the waterproofing membranes that are used, highly modified mortars, low absorption, large format tiles, gauged porcelain tile, and very small joints. You would think, as it used to be, the larger the tile, the larger the joint. We've defied all that. It goes to larger the tile. We can go down to very small grout joints now, giving very little area for the water to leave. The installation should be protected from rain and freezing temperatures before, during, and at least 3 days after the installation is complete. Keep these points in mind, selecting quality tile, waterproofing, mortars, grouts, and sealants that work together as a complete system. This should result in a beautiful exterior installation with high durability and longevity. Folks, I appreciate it. I'm done. I'd like to get your questions, and I'll be happy to answer them for you. And thanks again. I appreciate it very much.
Nick, great job. A lot of great information there, and we do have some questions. So I'll read them to you, and I'll let you answer them, okay?
Sure thing.
All right. So the first one is, will epoxy grout have these same issues?
They should not. I think I can't recall seeing efflorescence coming out of the grout. There have been a couple of times where I've seen where the epoxy grout wasn't completely filled, and there would be a micro crack or a micro fissure where the tile might meet the grout. And in that situation, I've seen very, very mild type of efflorescence, not so much latex, but I have seen very, very slight amounts, where there was like natural stone used, which also kind of gives me a little bit of a cringe whenever natural stone and epoxies are used. Always kind of the hair on my neck stands up a bit. But yeah, when it comes to epoxy, not much. I don't see it.
Nick, on this next one, I'm going to read you the question and then I want to make a comment first, okay?
Sure.
All right. So the question is, spot bonding with epoxy is an approved bonding method, I believe. This will allow a void behind the wall, won't water accumulation, carries soluble salts from the cementitious surface to the substrate to the surface. And first, I just want to say, Robert, spot bonding is not approved, not even with epoxy. There is one product in our whole all of the manufacturers, and it's a product made by Latex. It's a specialized epoxy with specialized tools you need to buy to use it. So spot bonding is never approved other than using Latex special programs. So I just want you to be aware of that. Interior, exterior, we do not approve spot bonding. Now, if you would like to, if they did do this spot bonding from Latex, and Nick, if there is a void behind the tile, like spot bonding creates, does water accumulation carry soluble salts from the cementitious substrate to the surface?
I don't see why it would not, Jim. Good question, and I appreciate the input. But yeah, spot bonding is not really approved. It's done, but it's not really approved. And the voids in between, once you squeeze it down to the floor, you squeeze that dollop down to about 1/8 of an inch, and that's close enough for migration of minerals through the that get wet behind it in those voids to transmit through the surface. And it could cause it to come out through the natural stone, particularly. But yes, I'm not real familiar with Latex system, but MAPEI does have epoxies that are used for setting. It's our Care Epoxy line, and it is used for setting of tile to have as much of a water-free installation as possible. I ran into it with Brazilian marble, the Brazilian rainforest marble. It's got a variety of colors, and one color it has is like an iron oxide red, and it's the actual roots of trees, but it's iron. There's iron content in it. Whenever the tile would get wet, rust would come to the surface. On countertops, on floors, wherever you might have used the Brazilian rainforest. And what we ended up recommending is a absolute waterless as possible, using mortars that didn't require water, such as epoxy. But that was full coverage epoxies too. We always recommend using the right notch trowel, 100% coverage, at least 90% coverage. That has to be checked periodically by popping a tile, making sure you're getting it, the ribbons are correct and covering the back of the tile. And using grouts that don't require water. There's a couple of grouts out in the market. Epoxy is one, but also these ready-to-use grouts that are out there, be them 100% acrylic or urethanes or hybrids. You don't add water. You put them out of the bucket, put them on the ground, float them onto the floor and into the joints. No minimal amount of water, and then sealing with a solvent-based sealer. You can use water-based because it evaporates quickly, but these preventative measures and using these materials greatly reduce the amount of moisture that can transmit through to the surface, bringing salts or latex or both.
So I just want to be clear to all of our attendees. He's not saying MAPEI has an epoxy that can be spot bonded, okay? We do
Correct.
not spot bond other than one program. You can reach out to Latex if you'd like to check into that spot bonding epoxy method, but it's the only one that is approved by our methods and standards of our industry. So just
Yeah.
want to make sure. All right.
Yeah,
Next
we
question.
don't make one that is for spot bonding, that's for sure.
Yes, yeah. So can leaching be finite or can it continue forever?
You know, that's a good question as well. Again, I refer back to making sure the root cause is addressed. I have a personal thing here at my own home. I've got about 1,700 square foot of Marazzi plank porcelain tile, and I have one spot at the highest elevation of my floor, actually, and I live on a lake, so there's groundwater. One spot about 6 inches wide and about 12 inches long, 3 grout joints that are have a latex that comes up all the time. We cannot determine why, but I've lived in this house for 7 years, and I can clean it today, and it'll be back in about 3 weeks. Starts out small, like one of the photos I had in the presentation that shows a clear liquid coming up in between the joint, and then it turns into a white crusty material as it dries and gets gets exposed to the air, and it dries. The only thing that we can think is there was a bowl in the slab, and the installer put a lot of our LFT, our large format tile mortar, down, and he probably went over the tolerances of thickness to just overcome that bowl, instead of putting something else in there that would have done better with a lot less latex, like maybe just a concrete mixture, and fill that bowl and then let it cure and then come back and put a good setting material above. But that's the only thing that we can think of, because we were actually coexisting in the house during the construction. To answer your question, I've had it going on for 7 years in my own personal house. One little spot, like I said, nowhere else does it happen. So broken pipe is kind of out of the question. It would be a lot larger area, or it would start expanding. All the other normal things were eliminated, and all we could really come up with is maybe just a bowl that's overfilled, and that has never had a chance to cure properly. Again, you got porcelain tile with 0.5% absorption. You've got open grout joints, and in this case, it's just coming up, latex modified, latex material coming up through the grout joint. And it became such an issue that I actually took the grout out of that little small area and just left it open, giving it more open time to maybe breathe out more quicker and hopefully eventually stop. Can it go on forever? I hope not. But and most of the time, if the obvious is taken care of, it should abate and be a finite type of a situation. In some situations, it can be an ongoing maintenance issue that just doesn't go away.
So to answer it shortly, it shouldn't be, but it can be.
Correct. Exactly.
All right, I have to make a correction here. One of our attendees did point out something I forgot to say about Latex epoxy system. It is only for vertical systems, okay? Not a floor epoxy. There's no spot bonding for floor tile, just so you know. So just wanted to clarify that real quick. All right.
Good point.
Let's see here. A lot of personal messages coming in here. A lot of people saying, great job, great information. Let's see what else we got here.
Thank
All right.
you.
There is one TCNA method that addresses spot bonding, page 202. It is for interior applications that will not withstand impact. MAPEI does have a spot bonding epoxy, Carabon SB. So I'm not familiar with that, but I'm assuming it's someone from MAPEI maybe that's answering that. Are you familiar with Carapoxy SB, Nick?
Yes, I am. And come to think of it, even though that's not on really my side of the business, it's I do recall the name now that when I said it, that we did not have one for spot bonding, I was questioning myself at that time. But yes, I am familiar with that product.
So everybody, here's what's the most important thing that you can learn from all of this. Great information. But if you question something, or if you're doing something you haven't done before, always check with the manufacturers, right? They have technical hotlines. You can go to your local distributor, wherever you get your product, talk to them, and they'll connect you with the technical people from MAPEI, with Nick and others. So manufacturers' recommendations supersede everything in the TCNA handbook and ANSI. So it's really important that you don't feel afraid to ask questions. Really, really important, because one little answer can save you hundreds, thousands of dollars. I mean, it's amazing. So don't hesitate, okay? And I want to thank everyone. I want to for sure thank Nick for all the great information. I want to thank all of you. And we had a huge audience today watching and listening to this presentation. I want to thank you all. I want you to know that we will not have another webinar until August 22nd, and that will be presented by Custom Building Products. But today we're thanking MAPEI and Nick. Nick, appreciate everything. Thanks, everybody. Bye-bye.
Thank you, guys.